Welcome to October's Void, Skywatchers. I'm Science Ben, Immersive Experiences Coordinator for the Danville Science Center, your guide through our tour of this month's night sky, and I'm going to be an astronaut for Halloween. Let's digitally step outside to discover this month's void. We're here in the backyard of the Danville Science Center. In the corner we can see it's just a couple minutes past noon on the 11th of October 2022. We are facing south. To the left is the east, to the right is the west, placing north directly behind us. Gazing skyward, we can spot a single star, the sun. We can't spot any other stars during the day due to the way the Earth's atmosphere diffuses the light of the sun. If we could remove the atmosphere, then we can spot the other nearby stars. For instance, today, the sun lies within the bounds of Virgo, the maiden. But that's not what happens. Instead, we have to wait for the Earth's rotation to continue on long enough to make the sun appear to sit in the west. That will happen tonight, shortly after about 7:30ish or so. Continuing on to here, it's just about 1 a.m. We can spot our bright hunter's moon high in the sky. October's full moon is known as the hunter's moon, marking the ideal time to go hunting for animals before the long, cold winter. The moon reached 100% illumination this past Sunday at 4:54 p.m., but will still appear very bright in tonight's sky at 94% illuminated. While bright, the moon will not outshine neighboring gas giants Jupiter and Saturn, each visible with the naked eye, though binoculars do help. A third planet, Uranus, is also visible near the moon, but you'll need a very good telescope to find it. Not here in Virginia, but skywatchers in the western United States may be able to use their telescopes to view the lunar occultation of Uranus tomorrow night, during which the moon will pass in front of Uranus, temporarily occulting, blocking it from view. Since the moon is so much closer to the Earth than the planets and other celestial bodies, its exact position differs with location, making lunar occultation visible from only small windows of locations at a time. Lunar conjunctions, however, are much more widely viewable. They occur when the moon appears really close to another object in the sky. We've already experienced two this month, one with Saturn last Wednesday and Jupiter last Saturday. Mars will experience lunar conjunction on the 15th. The moon will partially occult the sun on the 25th, resulting in a partial solar eclipse. Between 5 and 9 p.m., the moon will pass in front of the sun, blocking up to 82% of the solar disk. This display will only be visible for parts of Africa, Asia, Europe, and Greenland. If you thirst for a more domestic delight, October is a great month for a shower. There are many meteor showers on display this month. We can spot 5 overhead tonight that include the southern Taurids, which peaked last night, and the Orinids, peaking on the 21st of this month. The northern sky will feature the camelopardalids, Arugid, and Draconid showers this month. The Draconids being of note in that they are atypically more active in the evening rather than the morning hours. Last month, we took a peek at how NASA might protect the planet from space rock collisions. The DART mission did successfully complete its mission on the 26th of September of colliding a space probe traveling at 14,000 miles per hour into the asteroid moonlet of Dimorphos in the hopes of altering its current trajectory of orbit around larger asteroid Didymos. We are still some time away from discovering if said trajectory has been successfully altered. What, however, protects astronauts from debris impact while traversing open space? Spacesuits. Spacesuits do that, and so much more. People have lived and worked in outer space since the launch of the International Space Station on November 2nd, 2000. Inside the ISS, fashion favors comfort as the shared spacecraft regulates heat, pressure, and oxygen flow freely for all passengers. But exiting the space station for EVA, extravehicular activity, requires a personal spacecraft, the spacesuit. Over the past 50 years, 2,877 hours of successful spacewalks have been conducted in U.S. space suits. An ongoing marvel of engineering and composite of multiple materials, these suits don't just protect astronauts, but make their work possible. There are two main categories of spacesuits. One's designed for high visibility, and the other is built for dedicated functionality during spacewalks. Commercial suits are simpler, being needed only for emergency situations during launch and landing, but high-performance emergency suits have a more intense list of demands placed on them. Taking a stroll in low Earth orbit, astronauts must be protected from the vacuum of space. Temperatures can range from positive 120 degrees Celsius to negative 150 degrees. Sunlight exposure fluctuates from intense to absolute darkness as the Earth is orbited every 90 minutes. And of course, possible micrometeoroid or other debris collisions at speeds of 16 kilometers per second must be accounted for. Spacesuits must not only protect, but perform. Typical EVA work includes construction, repair, maintenance, and the running of experiments. Suits need to be able to mimic human mobility without exhausting their wearers. Just moving in microgravity requires a great deal of upper body dexterity as astronauts move through a series of handholds and tethers. When at a work location, foot restraints can be used to anchor the astronaut in place. Spacewalks can last 6 to 8 hours, so spacesuits also need to manage physiological needs. In addition to managing hydration and disposing of waste, components provide oxygen for breathing, remove exhaled carbon dioxide, absorb moisture created by sweat, and apply pressure to all body's surfaces to prevent the body's fluids from evolving into gases. The storage life of each suit is about 8 years for all soft materials and 20 for metal components. The entire system needs to be able to withstand the stress of 25 spacewalks. The greatest stress occurs at seams and joints, places where the suit needs to flex with human movement. Interchangeable components exist so that new suits do not have to be flown up with each change of crew members. But the section that receives the most stress, gloves used for extravehicular activity, are custom made for each astronaut. A laser scanner generates a 3D model of an astronaut's hand. That model is put into design software. Restraint patterns are generated that allow flexibility and comfort. Then those patterns are used to cut textiles that are sewn together to form the outer layer of the glove. The 3D model is then used to 3D print a physical replica of the astronaut's hand that is then painted and dipped in a flexible polymer to fabricate the inner layer of the glove. The rest of the suit is also constructed from a combination of textiles and flexible membranes. In addition to being sewn, they are thermally bonded together, making them airtight. The end result composite is similar to a football or basketball. Each suit is composed of 3 major layers: the bladder, the restraint, and the environmental layers. In the end, a thickness of less than 1/10 of an inch is what protects an astronaut from space. Suiting up begins with high-tech thermal underwear topped with an elastic bodysuit that has plastic tubing threaded throughout. Chilled water can be passed through this tubing to remove body heat from an astronaut. These 2 undergarments are also made of a wicking material that draws sweat away from the astronaut's body. The suit proper begins with the bladder layer. This consists of an impermeable polyurethane-coated nylon and contains the pressurized oxygen in the suit. It's designed to prevent moisture transmission to the vacuum-exposed side of the suit, where it would cause uncontrollable cooling via evaporation. Next is the restraint layer. It maintains the human form and keeps the bladder from ballooning. It's fabricated from sewn-together polyester, not unlike everyday clothing. Finally, the outer assembly of the spacesuit, the thermal and micrometeoroid layer, protects the wearer from partial impacts and solar radiation. It is made of ortho fabric and covered with white Gore-Tex, making the suit fire and bulletproof. The Gore-Tex is slippery to prevent friction between parts of the suit during movement. It's white to limit the absorption of solar energy. The ortho fabric is designed to break up hypervelocity particles, turning them into gas jets that are absorbed by the suit. Ball bearings are located in the arm, shoulder, wrist, and waist to assist with mobility. Metal ring locking mechanisms called disconnects are used to attach gloves and the helmet. The helmet, referred to as the bubble, attaches directly to the torso, restricting the range of typical neck movements. Moving with the suit on in general is not as straightforward as typical human movement, so astronauts go through a series of programming to discover how to best maneuver their personal spacecraft. Like all aspects of space exploration, spacesuits are under constant revision and improvement. Current models work well in low Earth orbit, but further exploration of space presents different challenges. Mars has 38% the gravity of Earth. The Moon, just 17%. Moon dust is sharp, but Mars dust is soft due to wind erosion. Creators are already busy at work developing the next generation of spacesuit to meet these challenges. Increase in space tourism and potential for developing extraterrestrial colonies means the spacesuits of tomorrow will need increased strength, comfort, and durability. Strength may be augmented through powered exoskeletons attached on the top of the suit, like those currently being used in manufacturing and automobile industries. Such robotics can add superhuman strength for construction or simply share a load to reduce fatigue. The suit itself may contain electroactive polymers that constrict like muscles when electrified. Biometric wearables like fitness watches and smart rings are already in use to monitor astronaut health. Soon, spacesuits will have wireless sensors that monitor the environment, the suit itself, and the wearer to autonomously adapt to given situations, alerting the wearer through voice or visual displays. Antimicrobial agents are being added to the bladder layer, the layer that comes in direct contact with the astronaut, to kill bacteria and viruses that are naturally expelled during respiration or sweating. These agents reduce odor, improve hygiene, and could lead to the creation of self-cleaning suits. This would prevent the need for return trips to Earth for laundering. Concepts are being developed that incorporate ultraviolet light or inflation with vaporized hydrogen peroxide to provide sterilization. Self-healing materials are also being developed for the bladder layer that can seal a hole created through regular wear or even puncture. American Scientist journalist David P. Cadigan describes a scenario where, when an astronaut exploring Mars in 2055 puts on her suit for the 250th time to repair the power generation system outside, it will be as strong and smell as fresh as the day when it left the factory. And it will passively seal the hole in the suit created when the robotic rover accidentally runs into her. Let's hope so. What are you going to be for Halloween? Feel free to share your pictures to the Science Center's Facebook page, especially if they are STEM related. Those are our favorites. Until next month's tour, the second Tuesday of November, November the 8th, I'm Astronaut Ben, reminding you to keep discovering your world. Bye.